Welcome to question A-4, 2018. So in this question, the graphic shows the spider cam used in aerial coverage of sports events. It is supported by 4 cables. The drawing shows the projections of those cables. So we've got these cables running down to our camera, and our camera is at point O. Okay, find the dihedral between planes A, O, B, and O. Okay, so these are the planes we're going to deal with. I'm just going to lightly shade them in just to make things a little bit clearer for us in this question. So we're dealing with OAB, so here's OAB. And OAB is here. And OAD, so OAD and OAD. Okay, so they're asking us to find the dihedral angle between those two planes. So we want to find point view of this line here. Okay, before I can find a point view of that line AO, I need to find a true length of that line. So using slide and set squares, I'm going to set up an auxiliary. Here's my auxiliary set up looking perpendicular to line AO. Okay, I use a slide and set squares here and project out those points. B out. Okay, so projecting from plan to an auxiliary elevation. So my heights are going to come from my elevation. So let's get the height there for D. Down to my XY line, and step up there for D. For A, it's at the same height, yeah it is, so A, same height. C, and here's C, I actually don't need. B is at the same height. Let's double check that. Yep, so B, and so that's and O, so height here to O. And let's label them up, so B, O, D, and A. Okay, so here is my true length line, AO, or OA. Just realized I've drawn that incorrectly. Okay, so B joins back to A. Okay. We've got planes AOD, Okay, Right, so they're my planes. So true length line, true length, and I want to see that as a point view. So use my sliding set squares, look out along that line, so looking perpendicular to it, parallel to it. Here's my x2, y2. So x1, y1, x2, y2. Okay, so plan to an auxiliary elevation to an auxiliary plan, so I'm going to go back 2 views to my plan, and I want to get the distances from my x1, y1 to each of those. So from D, A and O should be the same distance, because we're going to see them as a point view out here. And then the distance from my xy to B, and xy to B. I need to sling on B there. Alright, so here is an edge view of those planes. So here's the point view of AO. That's AO, or OA. Here's point D, and here's point B. Okay, so there are the edge views of my planes. Okay, so this angle here is the dihedral angle. Okay. So that is part A completed. Part B then, determine the angle between the cables AO and BO. So they want us to find this angle here. Okay? And AO and BO. Yeah. So what they essentially want us to do is they want us to find the true shape of this surface. Okay, there are a number of different ways we could do that. We could rotate, take an auxiliary looking out around here. Could we create a parallel line? No. Okay, handiest way I would say is we have an edge view here of AOB. So if we look out along that, we will get a perpendicular, or sorry, we'll get a true shape. So sliding set squares, come out a little bit. Draw my x1, y1, okay, and slide out my B, and over A. Okay, so coming back, quite a few views here. We have an elevation plan, auxiliary plan, and we'll have an auxiliary elevation here again. So go back 2 views to another elevation. My x2, y2, back to my views. That's the distances I'm going to take. So for point A, from my xy to A, and here is the position of A. My distance to B then, or sorry, to O, is going to be out here to O, and then distance to B from x1 or to x2, y2, and out to B. So that then finds us the true shape of that. So here's O, A, B. Okay, and just lightly join that across because it's just a light line. You can see here. So that is the true angle. Shade that in because that's that surface I was dealing with in yellow. So that's a true shape. Okay, so what we're really looking for is that this is the angle between those two. So that's the angle. Okay, so that is question A4, skew lines question, not skew lines, intersecting planes question in 2018.